Hey there, this is Prof. Aram, and in this video, we're going to look at the yield to maturity of the bond, what it is and how can we calculate it using the information that we have for a bond. So let's get to this. Yield to maturity is usually used to compare different bonds because you're usually looking at different investments in terms of the rate of return that they provide to you. So this is an annual rate of return on the bond if you hold that bond until maturity. So if you don't sell it and keep the bond until it matures, the rate of return that you will earn on the bond would be this yield to maturity for the bond. Another definition of yield to maturity is that it is the rate implied by the current price. In other words, it is the rate that makes the present value of the future cash flows, in other words, the present value of the coupons plus the lump sum that you receive at the end, equal to whatever the price is today in the market. That means yield to maturity is a market-driven rate of return, and it depends on the price of the bond on any given day. How can we calculate it? First of all, what goes into yield to maturity? So yield to maturity is the expected rate of return on a bond. So expected rate of return on any asset would be the risk-free rate plus some risk premium. In other words, if you are a risk-averse investor and you don't want to invest your money in a risky asset such as a bond or a stock, you're going to put your money in US treasuries, for example, which are considered risk-free. But if you are willing to accept more risk, for example, if you invest in corporate bonds, then you need to be compensated for it. You're going to demand higher compensation for taking on more risk. So that's why you're going to get rewarded some risk premium for accepting that risk. So finding the yield to maturity usually requires trial and error, meaning that you would guess a rate or a rate of return, and you find the present value of the future cash flows using that guess. And if the present value of those future cash flows end up to be the price, then that's your yield to maturity. But if the present value of the cash flows that you calculate end up being higher than the price today, then your yield, your guess was too low. You're going to increase that, and vice versa. You're going to keep changing the guess or keep doing this trial and error process until you get very close to the yield to maturity. But today, with the tools that we have, with the financial calculator or Excel, we can easily calculate the yield to maturity. So let's look at an example. This one is a yield to maturity for an annual coupon bond. So consider a bond with 10% annual coupon payment, which means your payments are going to be the coupon rate multiplied by par value. So you will receive $100 every year. That's your payment. That's the annuity factor in the bond. You have 15 years to maturity. The number of periods would be 15 years. And par value is 1,000. So we have future value of 1,000. And the price today would be present value. That's going to be 928.09. But remember, when we are putting these numbers in the calculator or Excel, this one should be negative. In other words, payment and future value always have the same sign, and present value or the price of a bond has the opposite sign. for example, the company who's paying these coupons and the face value, you would put negative for these two and then positive for the present value. So let's see what the rate is or what the yield to maturity is using this information. We're going to use the financial calculator first. First of all, I'm going to clear time value of money function. So in this case, we have a price of 928.07. Just make it smaller. 0.09, so 9. Our present value, 1,000 is the future value, 100 is the payment, and then we have 15 years to maturity. So the question is asking, first of all, would you think this yield will be more or less than the coupon rate, more or less than 10%? Because the price of the bond is less than $1,000. If you remember the relationships that we talked about before, because the price of the bond is less than $1,000, this is considered a discount bonds. And for discount bonds, the yield to maturity is always greater than the coupon rate, greater than 10% here. So we are going to find a yield that is higher than this 10% coupon rate. And as you can see, we have 11%. Let's look at the Excel sheet. So we have future value 1,000, 15 years to maturity, $928.09 for the price, and then payments are going to be 10% of 1,100. So the rate here is number of periods and payment would be 100. Present value is the price today, and then future value is the principal amount. You should get the same number here. Now, this is the simple case, but as you remember, most of the bonds in the US are paying coupons semi-annually. So let's look at a semi-annual bond. Suppose a bond with a 10% coupon rate and semi-annual coupons has a face value of 1,000, 20 years to maturity, and is selling for $1,197.93. So without even calculating this, you should be able to answer the first question. Is the yield to maturity more or less than 10%? Since we have a premium bond, that means that the yield to maturity should be less than the 10% coupon rate. What is the semi-annual coupon payment? That would be coupon rate times $1,000 face value divided by 2. So we will have 10% of 1,000, which is 100, divided by 2. We're going to receive $50 every 6 months. And how many periods do we have? How many 6-month or how many semi-annual payments or coupons are we going to receive? That would be 20 years times 2. So we receive 40 payments from this bond. Let's find out the exact yield to maturity for this bond. To clear the time value of money first, we have $1,197 97.93 for the price. Remember, negative sign. Let's see if I forget to put negative sign, but let's see what happens. And we have 1,000. Okay, wait. So this is your present value. We have 1,000 for future value, $50 for every semi-annual payment, and then we have 40 semi-annual periods, and then we can compute the IY. As you can see, we're going to receive an error 5, which is usually when you forget to do the sign convention. If I change my price to a negative number, then I'm going to get this rate. But you're not done yet, because this 4% that you find here is a 6-month rate. So your IY here that you calculate to spit out is a semi-annual. This is your periodic rate. The question is asking for yield to maturity, which is an annual rate. So what you need to do is to multiply this by 2 to get the annual rate of return or yield to maturity for this bond. Let's do the same thing in Excel. We have $1,000 for the face value. Number of periods is going to be 20 years times 2. And then price is 1,197. And then payment is going to be 100 divided by 2. So you have $50 every 6 months. So we calculate we find the rate. Number of periods is 40. Payment is 50. Present value is price here. And your future value is 1,000. As you can see, the 4% is your 6-month rate. So you need to find the yield to maturity. So yield to maturity equals your rate times 2. So your yield to maturity would be your rate multiplied by 2, which is 8%. I hope you find this video useful, and thank you for watching.